Hello, Peter here. I thought by now I was going on with lighting, but there were two things I want to share. One was a little bug fix. The other one is that I got a question about how to use the blob shadows on a slope. I will address both these things, but let's first do the bug fix because it's just very minor. That was in the component. In the event begin play, we set the scale of our cube. Now we took the radii here for x and y separately, but when we introduced rotation into the game, we could have a situation that if the radius for x is less than the radius for y, for instance, so it's not a symmetrical shadow, that when you start rotating, the shadow doesn't fit because it is not the cube rotating but the opacity mask inside the cube. So we need to change this by breaking those links. And take both of them to the side a bit and take the maximum of these and feed that into both the radius of x and y. Now this will ensure that if you start rotating your shadow, that it will fit into the cube and you don't get all kinds of weird cutoffs. So that is the little bug fix. It's not even a bug, it's more like a feature problem. Okay, the second thing was a question about how to use the blob shadow on a slope. Now the context of that question is how to use the blob shadow with a cutoff z very close to the radius on a slope. And I will show you what happens. Here we have the radii to 50 and the cutoff z to 56, which is close. And if we push this ball here, you will see the cutoff z will start cutting off the blob shadow. And that will be all the way on the slope as well. So that doesn't look well. Now obviously this is very simply removed by increasing your cutoff z. Fast demonstration of that. Blob shadow, put this to say 75 or something. That will be high enough. And you will not have the problem. It will look much more natural. So here we are. You see, this is how you want it to look. The problem with this though is that we use the shadows mostly for players and such, that increasing the cutoff z will make the shoes and the legs of the player black, because we just have a higher, we have a larger part of the mask available now, and that doesn't look well either. So can we do something about this, that we make this look okay with a cutoff z very close to the radius? Well, yes, we can. But we always need to take into account that we are not dealing with real shadows here. We are only simulating a shadow, and so we are tricking all kinds of things. So we can never really escape the fact that in our design and our coding of games using these things, that we need to be aware of that, and sometimes even deal with some consequences. But this particular problem we can do something about, and that is what I'm going to show you now. So let's go to our material function, the ellipsoid mask here. Just to be on the safe side, let's duplicate it so that we have the old one still there, and even we might want to choose to use that one instead for all kinds of reasons. Let's call that the mask simple. So it's the Ellipsoid Mask simple. And this is our alt one, and just save it. Now we have this one to play with. Now how can we solve that problem with the slope? Well, maybe you remember this bit here to make the cut of Z work. We looked at it as when the coordinates in the Z direction are going above some certain threshold, the cut of Z, then we need to put that value outside of the radius so that it's not part of the ellipsoid. So another way of looking at this is what we are doing here is testing if a point is either above, on, or under a plane. And the plane that we have is completely flat. It is the XY plane. And we have a cut of Z, and we look if a point is above or under that. Now, changing your view of the problem in that way gives a good indication on how we can solve the problem. Because instead of using only the Z coordinate, which is a very simplified way of checking if something is above, on, or under a plane, we are now going to look at the plane itself. Because that plane, we want to have the same orientation in space as the surface that our shadow is going to be on. So that means that this stuff needs to go. Let's delete that, because we need to do other things. I just want to have a bit of space here so that we have something to play with. Yeah. Now, the cut of Z, we are going to use and subtract from that the radius. If the radius is 50 and the cut of Z 56, we are interested in the 6 part in this case. So that is that bit, and we want to create a vector from this. So let's make float 3, hook up the Z there, and set the other ones to a constant 0. Now what is that? You can see this coordinate as a point on the plane. We know that whatever happens, the location, the coordinates 0, 0, 0 is on the plane. But that would be a cut of Z equal to the radius. So when we subtract the cut of Z from the radius, and we just add that to the Z. So we move the plane along the Z axis. Now we need a point to test. Well, you would be tempted to take this one. It seems the most logical one after the rotation, but that is wrong. We need to use this one, the world behind translucency, object position. That is our point that we are going to test. So what we need to do first is to subtract that vector and the point on the plane. And then we need to normalize that one. So now we're getting somewhere. Now the next thing we need is a new parameter, because we need the surface normal. So let's create a input, and let's call that one surface normal. And the type is a vector 3. And the default value, quite important, we set that with a Z to 1. So that will be the original situation with a completely flat surface. Well, flat, I mean aligned with the XY plane. Now, Then we need to do a dot product of these two and test what the outcome of this is going to be. So we are going to make an if. Like that. So the value we're going to test against is 0, though the constant b here is okay. Now, if the point is above the plane, then a will be greater than b. If it is on the plane, a will be equal to b, and if it is below the plane, a will be less than b. Now, the one that we do not want is the point above the plane. So what are we going to do to make sure nothing is happening when the point is above it? Well, basically the same as what we did before. We take the radius, add 1 to it. Constant b is 1 here. So this is going to be the value for if a greater than b. In all the other situations, we just want the original value for the z coordinate. Now this is going to look ugly, but we're going to straighten it out, make it slightly better, because we need to connect these both there. Right, now what do we have here? We now have a value for the z that is either the normal z coordinate, or it is put outside of the ellipsoid mask just to make it so that nothing will be seen, basically the cutoff. Now this one we need to now input into our divide by the radius as usual. Now let's try to make this a bit nicer, because this looks awful. Like that. And how can we make this bit better? Well, it's all about just being clear. Let's not waste time on trying to make this the best looking. You can do that yourself. It's much more interesting that you understand what happens. So we take a point, subtract it with a known point on the plane, normalize it, then do a dot product with the surface normal, and then we can test if that point that we are testing is either above, on, or below the plane. Above means, okay, it's cut off, so make it radius plus 1. In all the other cases, we just use the z. That should do the trick here. So let's see if we can save that. Oh, maybe one thing, did we check that the sort order of this one? No. I think we were at 11. Now we can save it. So now let's go to our material, and we see it now has an extra input. We need to create the parameter for that, and that is a vector parameter. And let's call that one a surface normal. And here too we want the b, which is the z, to be the default 1. And simply hook that one up. Then we can save this material. Now before we do anything else, let's just check that it still works as before, because these additions should not change anything right now. Right, we have our shadow here. And that is all good. And it works nicely because that is because we still have the fairly large cut of C. Let's make this 56, so it's very small. And also let's make the hover that I have to test these things unstable, so that we actually can see maybe the cutoff on the debug trace line. So 0.1, I think. Play that. Yeah, it's hopping nicely. Oh yeah, we see this little black tip on it. That's our 6 cutoff. The 56. So yeah, that's all great. Now let's make the code that can use this new parameter. Let's return to our blob shadow component. That was where we were last. But now we need to be here. And what we need to do is to move this to the side. I have no idea how much, but not too much. Right. So let's grab our dynamic material. Get dynamic. And we need to set a vector parameter value. And let's hook it in there before all the other stuff is done. Now the parameter name is surface normal. Again, very important to spell all this correctly so that the name of the parameter matches. Now what is the value? Well, that is dependent on if we have a hit or not. If we have a hit, we are going to use the out hit normal. That is the normal of the surface that got hit. If we have not hit anything at all, we need to create our own normal. So anyway, it's based on the result. So based on the result, we select either the hit normal, or we create one, and the one that we want in that case is the one that is aligned with the XY plane, so the Z is just 1. And this one gets hooked into the value. Now it creates this little... Oh, sorry, I don't know what I'm doing here. Double clicked it, I think. That wasn't the meaning. Okay, so it takes a linear color, so it converts that. That happens automatically. Yeah, I think that should do the trick. Yeah, let's see if that works. Compile, save. Let's do a play and see if it still works as before. Yes, it does. We have the little black tip, so that works. Well, we don't want this ball hopping about when we test it on the slope, so now let's stabilize the linear damping here again and see what happens when we push it onto the slope. Now what I expect to happen is that as long as the line trace is not hitting the slope, there will be no difference. So that means that entering the slope still looks not really good. You see that. But once it starts hitting, you see now it had the right surface. Normal. And then again, exiting the slope, you see you have that little problem. But yeah, you have to trick a bit with the right values of cutoff z to get that right. But that is not really the issue now. The issue now is to have this, and that is, yeah, really nice. It worked, so that's good. But yeah, this works for the use trace functionality. If I look at my normal shadow here, this is a fixed local z. And you will see that if I walk onto this, we have slightly the same problem. This is a very small blob shadow, so it is not really pronounced, but you see it start cutting in there. The cut of z starting to do its job. But this one doesn't use traces at all. And we're going to use our blob shadows, well, fairly often for players, I guess. So how can we make that functionality we just created available as a fixed local z situation? Well, what we can do is stop playing and go into the sphere here. Let's get rid of the hover here. Delete. So what will happen now is the ball will just fall onto the ground. But what we then need to do is to say, well, I'm still going to use trace, but I'm going to make my trace length very short, so that it seems like the shadow is always fixed at a local z. Now, an obvious error would be to make this one 50. That is not going to work. If we do that, we will see that there is a shadow. I can quickly do that. Let's play this one, and we will see that the ball is now on the ground and it has a shadow. It works on the flat plane really nice, but look what happens there. It still starts cutting in. It still starts to be like we had before. It's not, yeah, you see. Well, how did that happen? Well, that is due to the fact that when we use such a short trace length, the trace just simply doesn't hit anything when we come onto a slope. The trace is done perpendicularly straight down. So when we're on a slope, there will be some space from when the trace exits the sphere, there is a little space before it hits the slope surface. And that is not going to be enough here to hit the slope surface. So we need to increase this a little bit anyway. And 51, 52, it's all a bit too little. It depends on what kind of angle you have on your slopes. But if we would say, for instance, 65 here, that will probably work very nice. Let's test it. I should have moved my spawn point, but hey. Now this will look all the same. And now you see, this is exactly how I want it to be. And you will see when I put it in this kind of ditch here, if that is at all possible. Oh my god. No! Do it again. I want that ball rolling up there, so that we see the debug trace. Yeah, you see it? It's not hitting. And you see that's just very short. And that will give this is good enough. This will give the impression that it is a fixed local Z shadow. Let's stop displaying and let's do apply that to my Agatha player here. I have a blob shadow component here, but this one is using, where is it? Yeah, it is using not the trace. It uses a fixed local Z at the bottom of the capsule here. Now let's start using the trace, and I give it a trace length of 98. So just 10 longer, just like we did with the other, with the sphere as well. And let's see what happens. Compile this, play. Oh, sorry, that was not. Play it here so that we can see. Well, you see I now have the debug trace, and it's working exactly as before, because the trace length is so short that it, for all purposes, seems like I have a fixed local Z. But now when I walk onto this, I will not have the problem of it starting to be cut off because of the slope. So yeah, that is that problem solved. It was really nice that the question came up because I needed it myself as well. So now I have fixed it, and I hope this will be useful for you guys. Just another trick in the box to make blob shadows, yeah, even cooler. Well, hope you liked it. See you in the next episode, which I now hope really is about lighting, and bye-bye. Hello, Peter here again. Just wanted to say thanks for watching this video. Please let me know what you thought of it in the comments. Below there are links to other episodes in the series, and don't forget to subscribe so you are the first to know when the next episode is up. Thanks again for watching, and see you in the next video. Bye!